In this video, I would like to talk about a bonus part from the last project that we did together, namely how to use Faust, a generative audio library within Cables. So just so you know, it's not that simple to play and generate audio on the web. There are many different competing technology. Most of them are old and they are not very well suited for our use case, which is real-time interactive graphics. Because what you would like to do is have the audio thread doing its job, having the visuals on top, control, generate the audio, but not really interfere. But the issue with JavaScript is that by default it's only on one single thread, meaning that they can actually interfere and get laggy, where basically it gets laggy either in the visuals or the audio starts to be choppy. So the way to go around this issue is to use a more recent technology and new API introduced called web audio. But it's not that easy actually to play with. So, and they're also very, very limited. So another technology that was introduced on top of it, it was basically to reuse existing well-developed libraries that you could use to generate audio in different programming languages, and then compile them using technology called WebAssembly, so that you could now load this library as a compiled library, so something made in C or C++, for instance, or Rust, compiled to a binary that you load in your browser, and then have access to actually quite optimized DSP, so synthesizers, oscillators, all the basic tools you need to create audio on the fly. And this is basically what this library called Faust has been doing. It's actually quite popular. So what I've been doing is try to use the WASM, so the WebAssembly version, wrap it into Cables so that we can interact seamlessly with this programming language, like this DSP, so some kind of a programming language. I'm going to show it here, to generate some kind of effects, synth, instruments, whatever you can think of, and have this code run basically in Cables. So how it works is that you write the code, it's being compiled to this web audio API using and calling this from this WASM file, and it can be played in your browser without too much interference with the main thread that is dedicated to graphics. So if we come back to our projects, I'm not going to detail how I made the node. You can really inspect it. It's on the right part here. But you can. The cool thing is you can actually use these nodes as is. So how do you first get access to these nodes? Let me go back to Cables. I remember in previous videos we talked about the teams. So you can be part of a team, and a team can be public. So we have this team audio that is actually being created. So that's the URL, but I would suggest you reach out to us on Discord, and I'll because anyone, if you have the URL, you can just join, right? But it's very easy to join in. That if you don't find the URL, you just can ask us on Discord. And if you are part of this team, now you have access to these nodes, right? So I made the oscillator back in the day, and you see for Faust, so the library we're going to use, they are also for now have 4 nodes that you can use. So once you are in your project, then you can start to load the library, the team, sorry. And when you are in the team, then you will get access to these nodes. If I click on a node, you see it's in the namespace of this audio library. Okay. So quickly, if you skip the previous video, what we tried to do was just to create this spinning cube instead of using the regular mesh instancer, I was using the mesh instancer from Texture. And we also talked about how to use this external library to generate very smooth color palettes that we can, aesthetically pleasing to the eyes. And we're using this as a texture to randomly color these cubes here. Now, what's interesting here today is really to talk about the audio thing. So let me demonstrate what we'll try to do, and then maybe try to redo part of this. So let's listen to it. All right, so simple effect, but think of it as being generated completely within Cables, which is pretty cool. So I didn't really, I'm not an expert on the Faust programming language. What I use is basically use some of the examples there and ask a bit of ChatGPT to help me with this. The point is, if you know it, then it's going to be easy for you to come up with your own effects directly in Cables. Here we'll talk more about the mapping between the two. Let's get started. First, we are here and I'm just simply passing a trigger there because I want to keep the main loop and the graphics clean and have all the generative audio on this part. I'm using this trigger and I'm doing two things. First, I'm gonna talk about just there are actually two different sound effects that are layered on top of each other here. And this part on the left is simply about controlling basically here with the UI, basically controlling some of the effects that are generated in Faust. So this Cables texture was just a test. We don't actually ever really need any of these. What we need is first to load the library. So we only need to load it once, right? So I'm gonna use the trigger once from this main trigger loop and have this node load Faust. And it tells you, okay, this is the version 2.69.0. If you want to inspect the code, this is how I did it. And if you go back to my previous videos, we've seen now how to load and import modules dynamically. So it's the same thing, more or less. It's just, it's a it's a dynamic import there from the URL. It's just that the assets are being placed somewhere else in another patch, which is dedicated to just the library itself. Why am I doing this? Because otherwise I would have to copy and paste all the files, because it's actually not only a single JS file. As I mentioned, you are actually loading the compiled code, and so it's a bit of a mess to load many different files at once. And Cables at the moment does not really support anything else than a simple, as we saw, IFFE library loading. So basically have to go and fetch them from the assets there. When I'm loading the library, I'm loading all the everything that I can find in the Faust WASM library, and I'm mapping this to this global object in the main window, so that now it's easy for us to just check whether this object is defined. If true, then Faust is loaded, and then we can do wherever. If it doesn't work, if it's not loaded, then the op basically doesn't do anything. So assuming that we get our Faust loading here, loaded, what we would do now is we need, this play button. It's needed on when you open the page, and then when you start to click, it can be saved as a preference in your Chrome browser, so it doesn't necessarily need to prompt you again. But you need this. You need a user interaction technically to be able to start audio, and it's actually also a very good practice. I think we can all agree that nothing is worse than a website that starts playing audio automatically and you don't know where to turn it off. So just as a reference, if you don't know how to do this, you can always right-click and mute the site. I'm not sure if you see on the video, but just right-click on the tab, mute the site, and it will actually turn off the audio here. So okay, now we're there. We've just loaded the library. And now, as I said, we need to write some Faust code and then be able to map it into Cables. So this is the job of this node here, compile audio node. And it's also, it's a real, I chose the name carefully. It's compiling. So it means that it's not going to be instant. It's not running the code Faust in real time as fast as the rest of the Cables patch, which is always evaluated. Here, what you need is to set in a trigger, an impulsion, basically from the play button or a manual trigger here, to launch the compilation of the whole code. And then now, once this is compiled, you would get this fancy object here that we can visualize. And now, when this is compiled, then for sure you can use it and interact with it in real time. But the compilation is not, it's very fast, but if you have a big node, it's not real time, right? So that's a first thing to to consider. So you see, there's a lot of things, a lot of filters, libraries that are loaded, and it's infinite, right? This is what the Faust WASM give us, some kind of UI, and yeah, I will not. I mean, I made an op to actually simplify this. So this is the node we need, the object basically that is created when the code is compiled. So if I open the code, okay, this is one effect. This is a Faust code. And you see I mean, I'm not sure if you're familiar with it, but we just basically reproduce this kind of sliders. And we understand even that, okay, there is one called CT frequency, Q, and gain. And we technically are able now to map with the same nodes these values. So this is like the minimum, maximum, and the stepping, and the default value here. And what I'm gonna do after is, of course, modify these sliders in a way. So it's been in Faust, it's written as a horizontal slider, right? But don't think now we are in Cable. So any value that is basically moving from 0 to 1 can be used, doesn't need to be a slider at all, right? So we write this code, we compile it here, and then we compile it here when you run it, and then you have the play or stop button, right? If you want to play the music. So what I did when I found this actually quite interesting is to it's always playing in a way, because it was not actually that simple to stop the sound. There was some glitches. So I'm just mapping the volume here to 0. So if I turn it on, it's always playing in a way, and it doesn't really add any kind of performance issue. It's actually quite fast here. So I'm playing, the first thing I'm doing is playing with the volume here. So how I do this? I know that this volume is just a simple slider here from my sidebar. I'm using this value and I'm multiplying by 2 because I want to push the gain or not. I don't know why I'm remapping this to 0 to, I'm clamping it from 0 to 1, so it doesn't make, I mean, it's to make this slider go faster to the, but I think we can remove it, it doesn't matter. We just remapping to 0 and 1. I don't want to push this too far because it can actually not hurt your speaker, but it can be very loud. So be careful with the gain, right? At the beginning, always start with 0.5 and push it, because when you have like pure frequencies in your ears, it's really horrible. So, and be careful, right? So I have this volume, and what this node is going to do, set param value, is just going to find the path to where I've basically defined my sliders or my values that I can play with, and just set the value. So if I move here, it's moving in the background. So with only this set param value, it's the only node you need, and as long as you can put a path that is accessible from the Faust code, you can play with this here. And you can ask, okay, how do I know which nodes are available? Like what is the path, sorry, to each of the nodes? That's why in my compiled audio node, you have this input addresses. So they are input because technically you input this to Faust, right? Not output. So you see, I have the paths here. So I know, and if I go back to the code that we wrote, I mean, we didn't write them, but that I pasted here, you see that the CT frec is here, the gain is here, and the Q is here. So all these horizontal sliders have been exposed there as parameters for us to play with. And sometimes you have this slash DSP, it's the way the code is compiled and loaded. So if it's a high-level object like this, it's always below DSP, I think. And if you create a group, because you can also group like effects or whatever you create in Faust, then you would have the name of the group as an address basically here. So that's basically all there is to it. And of course, you have whether the node has finished compiled and it has errors or not. If you made a mistake, and you will, I mean, it's not that easy. So what I would suggest you do is you first make sure that it works here in this Faust ID when they have really built in. And okay, now basically take some kind of the code you wrote here and paste it in Cables. At least here you have the syntactic coloration. You can also play with it. I would not suggest to actually write directly Faust code in Cables because we don't have all these bells and whistles, but it could be a contribution that someone could add, right? And this is just the beginning of an integration, and I hope that this is going to inspire you to find more ways to develop this library. Don't forget that this team audio is open to all; anyone can contribute, and so that's the beauty of open source projects like this. So this is one object, right? They're creating actually this roar in the background, and I've basically added another effect on top of it just to show you that you can have multiple effects. It doesn't need to be contained in one giant Faust code. You can have multiple nodes, and so I did exactly the same technique with the other one. It's just I remap my volume again to my but this time is to a gate. So let's maybe inspect the code here. So you see I copy and pasted it right from the example. So you see it's a bit more complex, and yeah, what I have, what are the values that I can play with? Well, I know this one is actually a bit different because you need to click and have a gate button to actually have the sound being triggered. So if you go on Faust, you need to, I don't know if it's one of these ones that I found, and you just need to click on a button. Let me try to find, maybe, I think it's this guy, an example. So I found a trick that I don't know if it's correct or not, but I found this trick in Cables so that instead of having a gate between just 0 or 1, I'm just remapping this to a float. So I can really do the same, I'm using the same, almost like a slider, but it works also for a gate. So disclaimer, I didn't test all the possibilities of Faust, right? And maybe I don't have all the buttons or, this kind of button that you can click here in Cables, but from what I did, it actually works. So here you just need the gate to be through, so for the sound to be to pass, basically. So once again, we have this code here, and we can inspect all the addresses that you can play with, and these are like the bass frequency, the gain with the total volume, basically, whether you pass the sound or not, the gate, and the X and Y, which are basically some kind of effects that you can hear when you make the sound run, right? This kind of alarm moving with different basically parameters. So what I did simply now was just first, okay, to map this to the gate. So the volume acts a bit like the like whether like it's true, and if you pass it more or less basically through the gate, it's more or less loud, the sound. Here, this is something that we can play with when I move with this pitch here. It's just called pitch, but technically it's moving one of these parameters because the other one, the Y value, is always turning, and we can hear this with this sine wave. So if I don't touch anything and I'm just putting a bit of volume, you will see that this Y parameter is always moving. You see, it's a bit changing, right? It's not the same constant noise. So this is the Y value, and the X value is the bass pitch of this. So okay, that's this X parameter for you. So basically it's the same technique, right? I'm using now I'm in the cables realm, and as I said, this is a timer, but it could be an interaction with the camera, it could be some request that you get from the web, some data, anything you can think of. Now the two words are bridged in a way, and to me that was the main part. I've also added this polyphonic node, so it's not really working very well so far, but it worked. So basically for now, one node creates one sound on one channel, but you could imagine that you have many speakers, and then you assign each channel to a different speaker. So it's like you have many different sound at the same time. When you listen to a track, most likely you're listening to it in stereo, right? So you have two tracks, two channels, Here is just a monophonic channel, so one channel, and it's up to you to pan. So if we have a panner to say, oh, I'm gonna assign this to my left speaker, my back speaker, if you have Dolby Atmos and you want to specialize the sound, I'm not sure how advanced this is, but I know that you can pan the sound with the Web Audio API. So you can decide, okay, this effect here is gonna be on my left speaker, and this alarm one is gonna be on my right speaker. So that's when you can play with this polyphonic node there. And I invite you to look at the demo that I did on the Faust WASM demo to see how you can play with this polyphonic node. But just to give you the range of possibilities, you can play with MIDI as well. You can connect to instruments. You can, anything is that you can think of that is possible. Faust is actually very advanced as a programming language and possibility. It's just you have to learn how to do it, right? So yeah, and the simple part here is just a way to map the range here from the pitch, right? So you have to have a minimum value and to simply toggle or not on and off just here the X value. And this is just an experiment that I did that I could play with the scale of the texture or some color to so if I were moving it's changing the scale here. And then if you remember correctly, I can simply get my scale texture here. So I can var get texture, find my scale texture, and trying to map this to scale, right? So that when I'm pitching higher, the boxes are bigger. Otherwise, they go smaller like this. So, and it's the same technique. So I'm not really covering this, but we did this already. We just simply have a base color. So this is the black, and then we're just adding some values between 0 and 1, right? So it's very simple. It's just creating a gradient, but don't think of this as a texture. Think of this as an array of values that have exactly the same size as the position, and for each value each box we are mapping a scale, basically, right? So if I were to move this to something bigger, I could go beyond 1 and have the boxes a bit bigger, right? So I just simply need to add another RGB map, for instance, right? I could say, anyways, I want them to be bigger, so I'm gonna add 1 to every axis, right? So the minimum will be 1, and then they could just go bigger like this, right? So as I said before in other videos, we will do a special more tutorials about how to play with textures like this because I don't think it's really easy to reason about, but unfortunately that's the only way so far we can play with the very optimized GPU values within Cables, because we don't have the web GPU yet. It exists, but there's no clean binding yet from the web GPU world to Cables, and it's also very new. Not all browser at the time I'm shooting this video actually supports this. So for now, the way to be able to play with the values on the GPU is to use textures and not just create buffers that you could play with. So yeah, there you have it. This was a small bonus video on Faust, and I hope that you can really first enjoy it and also try to contribute, making more nodes and verifying that everything works correctly. It takes a bit of time to load because you have to load WebAssembly and all the binaries, but once it's there, it's actually very optimized, and it's not interfering with the main thread, so you can have very reactive graphics and cool sound like this. I hope you like this video, and I'll see you in the next one.